Okay, now the next advanced Swift topic is about closures, which are kind of like functions.
Well, in Swift, I guess they are functions. It is an interesting concept. In Swift, functions are sort of first-class citizens, as in they're as a type. They're just like integer. You can have integers, you have strings, and then you have functions. And it's interesting to think of them on that level. That means you can pass them around, you can assign them, you can even reassign function variables and stuff like that, which effectively makes Swift a functional language. And we're not going to go too deep into that, but closures are very widely used in Swift. And in this video, I guess, we want to explain how to use them and the basic concepts of closures. So we've defined functions before, and let's define a function here called, functions are always magical, so we perform more magic. And what it does is it takes in a thingy of type string, and it returns another thingy of another string, right? And it does magic on it. And here, this function just returns the thingy, so it actually does nothing. So the thing to see here is what is the function really? Like, what defines this function? And what that is it's sort of right here. It's this. This defines the function. This is the function's name. This is the function's parameters. It takes in one thingy. And then this is its return value. It returns a string. And so you can think of this as you're defining a function that maps a string to a string. Like it takes a thing as an input and gives back a string. And then you're naming it, perform magic. And this allows you to call it using its name. Or magic with name. So where do closures come in? Since this function is sort of just a named, you can think about it as like a named function. Right? It's this is the function. This perform magic is its name, and so perform magic is sort of a name for the function, and that's sort of like variables. So we can assign this as our magic function equals the perform magic, and note here I'm not calling it. Because this syntax, if I put it in the brackets, then I would be calling it, right? Like if I did this, I would be calling it, and then magic function would be the result. But if I don't call it, then I'm just assigning it directly to this other variable. So what does that mean? What is the type of magic function? Well, like I said, it's just defined by its inputs and outputs. A function has a type, and its type is completely defined by its input and output, right? Like if I had a function, and this allows you to call it later on. So now I can use this variable called magic function that got assigned to our perform magic function and call it on a string, and it actually will just call the same function. And as you can see, this method ran twice. So doing this is now equivalent to that, and that by itself is a pretty cool concept. and so with this, you don't even have to name functions anymore. So perform magic is a name function, so let's make this a variable. We're going to change it. So I'm going to define a function in code that instead of naming it, it's just going to directly be a function. And I can do that by using where are these brackets that indicate a function. And it's complaining right now because this already has a type. We're going to create a new one. Or a new magic function. This is already a function by itself. As you can see, it already has a type. Well, the type is it takes nothing and it returns nothing. So yeah, you can call it for fun. It actually does nothing. But how closures have their own syntax when you define them like this, you don't have a way to sort of put its signature. You can put its signature basically right after as the first line of the closure, and use the in keyword to specify that this is what it is. This is its type, its signature. And it's not going to give me an error because I told it that my function takes a string and returns a string, but I haven't returned anything. So it's missing the return statement. So now we can do the same thing. And now you have now magic function is again of a type string to string. And what we did here is we defined this exact same function in an anonymous way, because the function is defined here it still has the same exact type and even has the same parameter name, which really doesn't matter, right? We can change that to anything we want. But what's cool about it is it's anonymous, and you can assign it, and we call in Swift, this would be a closure.
Why is this closure useful?
Yeah, so that's a very interesting question. So it's actually very useful. So what you could do here that you can't do with this is you can now return this to a different, you can pass this around as a function.
We've now made an adder function. Great.
So what's cool is now you can pass this around, and you can have, so with functions you can do many more things, as in you can have a function that takes a function and applies it.
But couldn't you pass things around even if you declared the functions in a standard way?
Oh yeah, so the question is more why have this sort of anonymous function compared to this sort of name function?
Yeah.
This is just more convenient inside. If you were inside a function, say I had a function that did complicated stuff, and it's supposed to return a function, which is pretty common, or it takes a function as a parameter, and we do this often when, say, you have asynchronous, like a network thing, and you take in sort of the completion function. So I will go ahead and call my server stuff, and once it returns to me, I will call your function that you gave to me, sort of a completion handler. And it's so if this takes in a completion, and basically it does stuff, and completion is a function that does nothing, and it does crazy stuff, and when it's done, it calls completion. So when you're calling this function, it's simply useful to be able to define this function in line, right? So here I can say do complicated stuff and then do more complicated stuff, right? And this allows me to do this without having to go ahead and make this a function like this. Even though I could, it allows me to directly inline my closure when passing out this function. And the cool thing that we sort of touched upon here is when calling a function with a closure as its last argument, you can drop the parentheses and do it like this. So it allows for a more cleaner way to do this, and then passes in this completion closure.
Okay.
As this variable.
Again, this is something for our most of the applications we'll look at in this course. It's something that you may not have to use, but it does make writing code in some ways more elegant, in some cases easier.
This is something that may come up more than, sort of like optionals, it's very core to Swift. And a lot of functions, like I said, any sort of asynchronous operation, it would have to call, it can take a completion, like this sort of style will be very common. And so if you see something that wants you to pass in a function, you can do that. And it will call that for you, maybe on a different thread or after a while, right? Like in an uncertain amount of time. And you can continue with your execution without waiting for it. And also, closures are very useful in many other ways. And we'll see this along the way a lot. And I promise you, it will be very useful.
Okay, I guess right now the audience might have a question as to exactly how is this damage more useful than functions. We've tried to address that here a little bit, but I guess the real answer to that we'll see later on in different places when you actually start building applications.
Yes, and another whole side of closures is, if you're familiar at all with functional programming, you can chain. You do a lot of function sort of chaining. You can chain functions together to create a processing pipeline or of some sort. It's like you can take integer and then and pass it through a function that adds 1 to it, and then divides it by 2, and each one of those is sort of a function by itself. And you can write very functional code in that way that can be very clean when done properly. And so this, just by having this ability to define functions like this, unlocks basically that whole door to a whole functional world where code can look very different from the sort of empirical type of code we write commonly as well. That can result in another sort of different way of writing code that is very clean and safe. in lots of ways. Like, it has its own advantages as
Okay.
well. Yeah.
And we'll see that later on.
All right, so that's it for. Let's talk about one more thing about closures.
Sure. Okay.
So closures can do another cool thing, which is it can capture variables around it in its scope. And what that means is, say I had in my adder function, I only took one int. So what does it add to? Well, I can actually have a variable out here that's defined b out here, and this closure can add b. That's interesting, right? So when I'm calling it here, it's actually taking my 1 and adding b to it. And it's just very weird, because if you look at this function itself, say this function, you defined it like this. Say if you had this function defined like this, and you see this random b variable, that would be an error, right? Because it's a variable that was not defined in your function. But by defining it as a closure, it can actually capture this b variable within its scope, because you're assigning a variable here and you're creating this closure. It knows about b at this point. So in the function, you can actually use b, and you can even go as far as to passing this function to a different class, to a whole other function. And when they call it, they actually get the same behavior of b, which means that this sort of variable b is captured within this closure.
Interesting.
Mm-hmm.
So now one question I have is, you defined b to be a constant in this case, but if b was a variable, that would still work, I assume, right?
It would still work.
Now, if you changed b after the function was declared,
Mm-hmm.
how would that impact this?
So let's try that. And it shouldn't impact it, because it's called capturing, which means that it captures it, so it sort of saves its own, when it's defined, it saves its own internal copy.
So all the
Okay.
variables up to this
Yeah.
point when the function was declared, or this closure was
Yeah.
declared, have scope in this case, but then if they get changed later on, it doesn't really matter, because this is the point that this b at this point essentially is looked at as a 3. So whatever it has at this point, it's not a variable b, it's just the value here that's being directly used.
Yes, but there's also complications that can arise with, say you had a class, right? And now it is that class, correct? But then you can modify the internals of that class. And then this function will actually behave interestingly in many cases. So you want to avoid that, basically.
Okay. Or you want to try that
so
and
it
see
is
what happens.
Or you can try that and see what happens. But yes, so basically it is... I'm pretty sure it is possible to alter this behavior of the function sort of after it's been defined. If we have just a simple class for numbers and it just had, b in it, and it's default to 3. So if we captured instead and we defined a number here, we create one of these numbers, and we capture sort of, we capture number dot b in here instead.
Can you call this something else? Don't call this number, call it just
Right. A number. That was a bad idea. And I was actually complaining because of that. So this will still work. The adder function at this point will still work, right? But now if we change b to 5, will anything interesting happen? This is really exciting. I guess not. It's also because this class was not. Okay, I'm pretty sure there's a way we can massage this to get the behavior we want. Oh, actually, yeah, it worked. Now it's 6. So if we call this twice, you see how the first time it was 1, and then you changed it, and it became, and now it's 6. And this is because in this function, it's capturing this class, which we'll talk about very soon, is a reference type, which means when you do this, it doesn't make a copy of it, right? Unlike a integer, you pass it around and it creates copies of it. It's now a class. So you can change this, and this function now behaves differently. And like I said, this is very dangerous behavior, I would say. So you might want to avoid doing this. But as we can see, you can use this. I mean, there are ways to use this and create interesting programs.